Okay, I guess I'll start. So hi, everybody. Welcome to our very first STEM It Up event. My name is Sophia. I'm a fourth year biology student, and I'm also a student ambassador as a part of STEM It Up. So just a little bit about our project. I guess I'll start. So hi, everybody. Welcome to our very first STEM It Up event. Your feedback, Sophia. Here we go. That's okay, no worries. Like, whoa, I hear my own voice. No, it's fine. Okay, so just a little bit about our project to start. So STEM stands for science, technology, engineering, and math. And so our project is all about encouraging STEM learning and getting young people like yourselves engaged and excited about STEM. And yeah, so we're going to do that through a bunch of fun and interactive activities, just like our event today. So our program today is actually made possible by our partner, Astronomy Action. So Astronomy Action creates live stream programs that basically allows you to explore the night sky as viewed from your location. So you can view constellations and planets and fly around the galaxy and so on. And all of their programs are really cool because they're inquiry-based. They encourage participation. You guys can ask your questions. And basically the participants are really driving the program. And so this highly visual experience really seeks to show you how cool our galaxy is as you're guided by a professional astronomer. So now Alyssa can go ahead and take it away and introduce Ryan.
Hi, everyone. Thank you for coming to this event. My name is Alyssa, one of the other student ambassadors for the STEM It Up project. And I would just like to introduce Allison Canning, who is the executive director for the Let's Get Together, which is also a sponsor of the STEM It Up project. Allison is also one of the directors for the STEM It Up project who guides the student ambassadors, and she has played a huge role in facilitating these STEM It Up events. I would also like to introduce Yara. She's one of our junior student ambassadors from the STEM It Up group, and she actually designed our logo, so she's really talented and artistic. And I will introduce Ryan. Ryan Marciniak is an astronomer, science communicator, and founder of Astronomy Action. With 2 portable planetariums, Astronomy Action brings the universe to communicate across Ontario. Audience see stunning 4K visuals of the true night sky and a professionally presented 360-degree theater, allowing guests to experience the universe with wonder and awe. He also does live stream workshops across Canada using amazing visualizations of the universe to educate and entertain.
Was that my cue? Shall I get started? Oh, look, they're nodding. That's wonderful.
Yeah.
I'm so glad to talk to everybody today. I know all you see is a logo, but there is a person behind that logo. Thank you for that lovely introduction. You actually pronounced my name correctly, which is really wonderful. So let me say hello. Hi, nice to see everybody. My name is Ryan, and I am your personal professional astronomer for the next hour. We're going to talk about some really cool space stuff. And I do love questions. I'm curious to know what you're curious about. So please type lots of questions in the chat. I'm going to keep an eye on the chat. So if you ever see me looking over here, that's our chat. So I'm happy to answer any questions as we go along about anything. We can see a lot of fun stuff. And usually I end up doing these streams for like an hour and a half, but we don't have as much time. So I want to get lots of great questions from you as we go through all this stuff. But I promise you're not going to have to look at this lovely face the entire time. We're taking a visual journey through the universe, and that's what's more fun about it. So is my screen pinned? Everything's good? We're all set? Wonderful. Thank you, my friends. Let's get together. Let's get started. Let's get together. Let's do it. Okay, I want to show you the sky right now. This is what our sky looks like outside right now. Unfortunately, it's winter in Canada and there are clouds. But as an astronomer, I don't believe in clouds, right? Don't believe in clouds. So we can see a couple of things up in the sky right now. Does anybody see any stars? Tell me in the chat if you see any stars up in the sky right now. We do, this kind of looks like a star, but believe it or not, that's our moon. We do see the moon there. So very, very bright. You can actually see it in the daytime sometimes. And oh, very good. Yes, a couple of you. Yeah. Jaya got it right out. I hope I said your name right. Sorry if I didn't. The sun, absolutely right. The sun is a star, just like all of the stars in the night sky. The sun is the only one that's bright enough that we can see in the daytime. And you know what that also means is that all the stars in the night sky are also suns. They have their own planets and moons and asteroids and comets and maybe even life. Kind of cool. And if we're going to get rid of all the air around the Earth. So everybody, please take a nice deep breath. We're going to get rid of all the air. Here we go. 1, 2, 3. It's okay. You can breathe. I was just kidding. Oh, that's all right. Please continue to breathe. But if we get rid of all the air, look at that. You can actually see stars in the daytime. So the reason we can't see stars in the daytime is because of the one that's closest to us, the sun. It's really bright. Its light bounces around in the atmosphere and blocks out all the stars. But when it's dark, or if the air was all gone, we can see a lot of those other stars, a lot of those other suns. So let's turn the air back on because we generally need that here on Earth. And we're going to go to tonight. We're going to go a little bit later, let the sun set nice and early. We see the moon kind of follow it down and we get to see some stars. Now we'll just take a quick close-up look of the moon and go all the way in, and you can see that we're just at the very beginning of the moon cycle. We're going to see this nice thin crescent. And if I look outside my window right now, it looks kind of clear. So I'm hopeful that tonight will be nice enough to see the moon just after sunset, that thin little crescent moon. But if we look at the moon tomorrow, it looks like this. And if we look at the moon the next day, what's the next day? Monday? Yeah. I lose track of time now, I tell you. Monday, Tuesday, Wednesday, Thursday, Friday, every day the moon moves a little bit of the way around the Earth and gets a little bit brighter until it reaches full. And then it starts to go, whoa, that's close to the horizon. That's why it looks kind of flattened. So let's go all the way back to today, though. What day is today anyway? Holy smokes, January 16th. Time flies when you're having fun. And that means that the moon actually takes about 29 and a half days to go all the way around the Earth, all the way around. One orbit of the moon is 29 and a half days. And guess what? We call that a month. Moon kind of sounds like month, right? So that's where we get that term from. So 1 month, one lunar cycle. And our ancestors, a long time ago, they used to look up at the sky and they realized that every time the seasons repeated, every time you would have spring and summer and autumn and winter, they would see the moon work through the sky 12 times. 12 moons, 12 months in 1 year. And the seasons repeat every year. So that's where it all comes from. Now, if we look up in our sky, we can see there's this big streak of light that goes all the way across the sky. Can anybody tell me what that is? Anybody tell me what that is? It's big, it's bright. It's kind of hard to see when you live in the city. It's really hard to see when you live in the city because there's lots of bright lights that kind of shine up and block out stars. But if you've ever had cereal for breakfast, I'm sure you'll know exactly what this big streak of light is. So please do tell me if you get a chance. But it does, we see a lot of stars there. And if we kind of zoom in on it, you can see a lot of stars, a lot of different things. Oh, a galaxy and the Milky Way, two great answers. And those are both absolutely correct. Ali says a galaxy and a galaxy is right. And Jaya says the Milky Way and Lavina says the Milky Way. You're all technically right. This is the Milky Way and it is a galaxy that we live in. We call it the Milky Way because it looks like milk across the sky, right? But 3,000 years ago, the ancient Greeks, they looked up at this thing in the sky and they said, wow, that looks like milk. And so they named it after their word for milk. And the ancient Greek word for milk is galaxis. And that sounds like galaxy, right? So that's actually where we get the term galaxy from, was milk. So every time you see a galaxy, you should immediately think, wow, that's milk. There you go. So lots of milk up in the sky. Some other things to look at in the sky, and I promise we're going to go visit this galaxy pretty soon that we live in. Some other things to look at in the sky if you happen to go outside over the next week or month or a couple of months, aside from the moon, which we can see slowly working its way across the sky every day. So, you know, every day it moves a little bit further along as well. Another thing you can always spot is the bright red planet Mars. You can see Mars right now very clearly. You don't need a telescope or binoculars or anything to see it. It's right there toward the south sky, basically all night. I think it'll set probably around 3 o'clock in the morning or so. And if you look at it with binoculars, it looks even more red, but it is bright. It is red, it is a big dot, but it's also a world. And if we zoom right in, you can see that it is in fact another planet, a place that hopefully we can visit someday. It's called the red planet. Now, is Mars hot or cold? Is Mars hot or cold? That's a good question for everybody in our chat today. Tell me what you think. Is Mars hot or cold? I also don't believe in wrong answers. There are answers that might be wrong in one context, but are correct in another. So, okay, Sebastian says hot, Micah says hot, Alyssa says hot, right? We always think of things that are red as hot, right? Fire, if you see a burner, it gets hot, it turns red. And that's very true when it comes to stars. But, oh, Yara's got it right. It's cold since it's far away from the sun. Mars is a cold planet. It is minus 40 degrees on a normal day. And I'm going to show you why. If we look at our solar system, we see that the planets around the sun, think of the sun like a campfire. If you've ever gone camping or even just had a fire at home in your fireplace, the closer you are to the fire, the hotter it is, right? So Mercury is that person who's very, very chilly at night and just likes to sit right next to the fire and just absorb all that heat, even though most other people would get burnt and can't stand it. So Mercury is the one who can take it. Venus also likes the warmth a little bit. Planet Earth, we're, pretty chill, not too hot, not too cold, just right, what we call the Goldilocks zone. But Mars is the one who really likes the outdoor experience, loves the fresh air, and gets warm all the time, way too fast. So Mars is a little bit further away from our campfire, a little bit further away from the sun, so it gets less energy, less heat, and that makes it cold. And so even though Mars is a relatively livable planet, it's cold, even though it's red too. So the reason Mars is red is because of the soil that it has on it. Mars's soil has rust in it. So if you've ever seen an old piece of metal or an old car get rusty red, that's what is covering Mars. And if we had a big broom and swept away all that rust, if we could sweep it all away, Mars would look a lot like the Earth. The rocks would be brown or gray or sandy, the same color as Earth rocks. So Mars is basically like a big cold desert. And not a big cold dessert, although that does sound delicious, that it is a big cold desert with not much air, not much water, very chilly. Now, a tougher question for all of you, what are these two dots that are next to Mars? This one here and this one here. Any ideas? What do we think? Oh, Yara's right on it. Moons, that is absolutely right. Yeah, okay. Geez, we're getting much better at this as we go along. I've got some very intelligent friends here today. Mars's two moons, that's right. They are called Phobos and Deimos. Now, there's two moons. That's twice as many as Earth has, but Earth's moon is about 200 times bigger than both of these little guys. They're pretty small. They're basically asteroids. They're rocky. And we know Mars is the god of war in Roman mythology. Phobos and Deimos were the sons of Mars in mythology, and their names literally mean fear and panic, which is kind of creepy because Mars is like the god of war. And so it makes sense. The sons would be fear and panic. And so Phobos, phobia, you get the idea. So there we go. I want to show you a little trick though. If you're outside, unfortunately we don't have these big labels up in the sky to tell us what things are. I mean, we all have devices and we can do that, but the letters M-A-R-S are not up in the sky. So there's a little secret that I want to tell you for how to find planets in the sky. And the way to do that is that if we look at a star, this particular one, doesn't really matter which one, but we look at a star up close. Whoa, it's like wobbling, it's pulsing. What do we call that? What's it doing? It's going blob, 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 blob. It's also an excellent children's song, right? It goes like something, something, little star. Well, that kind of gives it away, but that's okay. You get the idea. So this star pulses, it wobbles, it twinkles. That's right, it twinkles. Very good, Sebastian. It twinkles. And so it's because a star is so far away, it basically looks like a tiny little dot. And that dot, when the air in our atmosphere moves between us and that star, that dot starts bouncing around all over the place. Bing, 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 bing. And that's what causes that twinkling effect that we can see here. And if we want to, kind of like a diamond, exactly right. They sparkle. Stars do really sparkle when you see them. And all of that happens because of the atmosphere, the air that we breathe. But if we get rid of all the air, once again, it's okay. You don't have to hold your breath. We know that I'm not going to suck all the air out of the room. The star stops twinkling. So stars twinkle because of the atmosphere. And if you ever get to be an astronaut, if you ever get to go into outer space and look at the stars don't twinkle in space, which is kind of crazy. Lavina says, isn't a star an asteroid? An asteroid is a rock, typically. Whereas a star is something that's made of gas and causes its own light. And stars are often much, much bigger. Asteroids are a lot like planets. They're rocky. They reflect light. They don't make their own light. And asteroids are also much smaller as well. Okay, so great question, though. We might take a look at a couple of those asteroids. In fact, Mars's moons, Phobos and Deimos, were thought to be asteroids that Mars captured with its gravity. So your secret, though, is this. That star twinkles because it's so far away. It's a tiny little dot. But when we look at Mars, Mars doesn't twinkle. And that's because Mars is closer to us. It's big. It has size. So even though there's air moving between us and the planet doesn't twinkle. It doesn't bounce around. It just ripples. And if you ever see a planet in a telescope, the planet looks like it's underwater. It kind of ripples, which is pretty cool. Now, Lavina, since you asked, I'm going to show you an asteroid. Let's pick a good asteroid. Let's go over to, let's see the Earth. The Earth is not an asteroid, believe it or not. But let's go find one. And I know there's a good one. I mean, let's look at Mars's moon, actually. Let's look at Phobos. Because Phobos is basically what an asteroid looks like. So if we go all the way to Phobos, flying through space, this is what I love about this particular program. It's called Space Engine. Lets us do some fun things. So here we go. This is Phobos. Pretty funny looking, right? Doesn't look much like our moon. It's got some holes on it that we call craters. It's only, how wide is it? Yeah, 21 kilometers wide, which is, sounds like a lot, but this is your typical asteroid, basically. Rocky, dusty, not doing very much. That's about it. So that's what we look at when we see an asteroid. And in this case, it happens to be a moon as well. Some other things to look at in the sky at this time of year. Oh, beautiful things. Well, we have the planet Mars. One of my favorite constellations is way up high in the sky right now, and that is Orion the Hunter. Oh, you're very welcome. Thanks for asking. I love questions because it shows me what people are curious about. And it's more fun to talk about the things that you're curious about than a bunch of things that I know, right? Because I could talk for hours about anything space related, I should say. But when you ask questions, that tells me what you want to know and where you want to go. Because this is your adventure, not mine. So here's my favorite constellation, Orion the Hunter. It actually kind of looks like a person, which is kind of neat. We can add in the art if you really want to get that effect. But Orion has a couple of really notable things in it. It's very easy to recognize. We typically look for these 4 bright stars that kind of form a diamond or a square, I guess, rectangle. And then these 3 belt stars right here. And just below the belt of Orion is the sword. And in the sword is this really amazing object that we call the Orion Nebula. So this is the Orion Nebula. A nebula is a place where stars are born. This is a place that it's a big clump of gas and dust, and it's forming new stars right now. And when those new stars are born, their light shines and causes the gas and dust around it to glow. And you can actually see this without binoculars or a telescope from even the city. You look at it and it will look like a little fuzzy patch. And that is a star nursery. It is very beautiful. And actually, there's a lot of people who are astronomers and astrophotographers who take pictures. And often they take pictures of this nebula because it's so big, it's so beautiful, it's very bright, so it's easy to capture. And there are some really gorgeous images of it. I actually want to see if I have one of those images, because I have a ton of random pictures kind of kicking around. I might not. I don't think I have it on me right now, but there's a lot of really nice pictures that you can find of it online. And it's really easy to spot. If you do have binoculars or a telescope, it'll actually, you won't see all these colors. You'll actually see a little bit of green, which is what our eyes can pick up, or gray, because it is very dim. So it'll look really nice through binoculars or a telescope. The other thing to look at in Orion is these 2 stars. This blue one down here and the red one up here, they are red and blue, and they do have these distinct colors that really help you can really tell that there's a difference in the colors as well. And so that blue star is Rigel, and the red star has a great name, Betelgeuse, one of my favorite stars. And the reason it's one of my favorite stars, it's really gigantic. I'll show you how big it is a little bit later. Really gigantic. It's bright red. But one of the things that's really interesting about it is that, are black holes real? Absolutely, they're real. I promise we'll talk about those a little bit later. One of the things I like about Betelgeuse and most stars is that stars, their names are Arabic. We have a sky that is based on three cultures. The Greeks are the ones who named the constellations. So the constellations are all Greek. The planets are Roman or Latin, that's Mars. And the stars have Arabic names. And that's because about 1,000 years ago in the Arabic world, that was the center of astronomy. And so they named all these stars from the ancient Greek catalogs. And one of the things I love about it is that this star Betelgeuse, if you translate its name from ancient Arabic to modern English, it literally translates to the armpit of the Great One. And so that is the armpit star. And you'll never forget that, I guarantee. So when you do see that star, just think, oh, that's the armpit of the hero. Yeah, that's fun. Is this because the technology advanced as the civilizations did so they could actually see the individual stars? It's part of that. The bigger thing with the Greeks is that they named the stars based on the constellations. So for example, Orion has these bright stars in it. Rigel down here literally means like the knee of the hunter or the foot of the hunter. Betelgeuse is the armpit of the hunter or the armpit of the hero or the armpit of the great one, right? So the stars and basically were named for the parts of the constellations. So the Greeks didn't really have names for them. They just said, oh, here's the constellation and that star is, the eye of the bull, Aldebaran. That's what that literally means. And then it was the Arabic world that took those definitions, like the eye of the bull, and translated it to Arabic. And those are a lot of the star names that we have today. Great question. You're very welcome. So that's a good one to see is Orion the Hunter. Just down from Orion, well, we'll talk about that after, but just up from Orion in Taurus the Bull is this beautiful little clump of stars that we call the Pleiades. Pleiades are known as the seven sisters in mythology, the seven princesses, and it's a little star cluster made of thousands of stars. But with just your eyes, you can see up to 7 of them. So if you go outside in the city and you look at that, it kind of looks like a Little Dipper a little bit and is often confused for the Little Dipper, but you can see up to 7 of those stars. Now, people used to use this as an eye test. They used to look out at night thousands of years ago, and if you could see all 7 of them with just your eyes, they had no binoculars or telescopes back then, you could see all 7, it meant you had really good eyes. If you can only see 1, okay, maybe you're not going to be a scout, maybe, or an archer. Maybe we'll give you a different job in the military, right? Why is Pluto not a planet anymore? Yeah, I'll talk about that too. Thanks for asking that. So we're going to talk about black holes, and we're going to talk about Pluto. So the Pleiades is absolutely beautiful. All these stars are bright blue, very, very young, only a couple 100 million years old, which sounds like a long time, but to a star, that's like, I don't know, 6 months old, basically. So they're very, very young stars. Very bright, very hot, very easy to see, and they look beautiful in the sky. So that's a good one to take a look at. And if you go a little bit later on in the evening, you can start to see the brightest star in the night sky down here. Whoops, I must have clicked the wrong thing. That is the star Sirius. It's a very serious star. Literally is the dog star because it's part of Canis Major, the big dog constellation that actually kind of looks like a dog. So that's the dog star. Canis Major is the constellation, and it's a very serious star, as we now know. It's the brightest star in the night sky, not because it's the biggest, but because it's very, very close to us. Okay, so that's a good thing to take a look at. And one more thing I'm going to show you to look at in the sky, excuse me, that is a little bit tough to see, but it is up there. I just have to find it myself. Oh, there it is. Okay, so in the northwest, there's a little fuzzy patch right here. No, that's not it. This is it. That's the Andromeda Galaxy. This is the closest large galaxy to us. A galaxy is a big collection, I suppose, of stars, and not just a couple stars. This galaxy has over 400 billion of them, which is a 4 with 11 zeros after it. So quite a huge number. And our Milky Way also has that many stars, but of course we live inside it, so it's kind of hard to see them all. But you can see this galaxy. It is the closest large galaxy to us. You can see it up in the sky toward the northwest as a little fuzzy patch, even from the city. In fact, this is the most distant, I said farthest, but the most distant object that you can see with just your eyes in the night sky, the Andromeda Galaxy. Pretty amazing. And actually, this is one of my favorite pictures in all of astronomy. I'm going to show you is a picture of Andromeda. So let's zoom in for a second. Now, the picture I'm going to show you is kind of the top corner of this galaxy, or the top corner of this galaxy. Okay, so this is my favorite picture in all of astronomy, which is definitely saying something. Yara asks, is it possible to travel there? Probably not. I mean, yeah, okay, so technically it is possible to travel to this galaxy. It is possible to travel to this galaxy, but even at the absolute fastest speed you could travel, at the speed of light, it would take you about 2.5 million years to get there. So you're going to be traveling for a while, and you're probably not going to be you anymore by the time you get there, right? So it's very far away. Now, the speed of light is so fast that you could go around the Earth 8 times in 1 second. That's how fast a beam of light travels. And at that speed, it would take you 2.5 million years to reach this galaxy. It's kind of unfathomable how far away this stuff is. But I want to show you my favorite picture again. This is it. And the reason I love this picture so much is that when I say a galaxy has 400 billion stars, that's a big number, but it doesn't really mean anything, right? Like I can't imagine 400 billion of anything. Like I can't imagine what 400 billion snowflakes would look like. I can't imagine what 400 billion grains of sand would look like. This helps a little bit. This picture has such a high resolution that we can actually zoom right in and see every individual star that makes up this galaxy. See all those dots? Those are stars, every single one. Some are blue and red and yellow and white. And it doesn't matter where we go in this galaxy. We can go over to the darkest parts of it over here and zoom in, and there's still stars everywhere. We can go to the very center and look for the brightest parts, and still it just looks like sand on a beach. And those are all individual stars that are very far apart, just like the stars in our night sky. Oh, and thank you for asking that. Rodrigo got it right on the head. How much space is there between each star? Most stars are anywhere from 4, or I'd say maybe 2 to 10,000 light years apart. To clarify, a light year is the distance that a beam of light could travel in 1 year. So, again, if we're talking about that beam of light that can go around the Earth 8 times in 1 second, imagine how far that beam of light could travel in 1 year. The closest star to the Earth, other than the sun, is 4 light years away, 4 years at the speed of light. Okay, so that kind of puts things into perspective. So things are very, very far apart. And even in this galaxy, although these stars look very close together, they're actually immensely far apart. Space is huge, and that's the craziest thing that I can tell you today, is that space is just huge. So thank you for those questions. Those are really great, and thanks for mentioning that. Let's go and let's go look at some planets. I promise I'm going to talk about Pluto next as well. So that's the Andromeda Galaxy. You can actually see that galaxy. And are those big light stars too? Really smart question, Lavina. I like this one a lot. So these big things, those are stars, but those are like this one here or this one up here. These are stars, but these are stars within our galaxy, within the Milky Way. So think of it like this. Those big stars are kind of right in front of our face. The smaller ones that are part of that galaxy are like across the street. That's kind of what it means. So these are often called field stars. because no matter where you look, we have to look through our own galaxy as well. Okay. I hope that makes sense for you. But basically, they look bigger because they're much, much, much closer to us. Still very far away, but much closer. Okay. Wonderful question. I like that a lot. And that's our Andromeda Galaxy. And the really cool thing about seeing this galaxy is that the light that came from it, the light that you're seeing that hits your eyes when you look at this galaxy, that light has been traveling for 2.5 million years through outer space to reach your eyes. That's kind of cool. All right, so let's go talk about the solar system. Sorry, just getting a drink of water there. I talk a lot, so my voice gets pretty raspy pretty fast, even though I've been doing this for years. We're going to line up all the planets right next to each other. This is a program called Universe Sandbox. It is a paid software, but I think it's about $40 for a license. And it's really fun. You can crash stuff together, blow stuff up. We might do that. But I'm going to start with the Earth. This is where we live. And actually, we're right about there. So if you want, you can wave to yourself. Look at that. Hey, hi, us. There we are. We live right there. There's like Ontario, somewhere around there. Yeah, there it is. So we can wave to ourselves. The Earth is pretty big. It's a planet. And I'm going to compare it to the moon. I said before that our moon is actually quite large, right? So the moon is about this big. It's about 1/3 to 1/4 of the size of the Earth. Pretty big. It's also much further away than this. The moon is about 30 times the diameter of Earth away from Earth. So what that really means is that if I tried to place the moon at its actual distance, it's way, way, way out here, probably about here. 384,000 kilometers. Very, very far. Okay, but that's about how big they are. And the closest planet to the sun, we're going to bring that one up first. I know you know what it is. If we're on Earth and Earth is in space, then does that mean we are a species of aliens? Alien kind of refers to a species that is not of Earth, right? Or something that is not of this place. That's generally the term alien. So if there is life on another planet, to them, we are the aliens, right? So that's just kind of a general term that we use for life that exists on another planet. Oh, that was the moon again. I did not want to place the moon, but look at that. We can have as many moons as we want. I want to actually start with the closest planet to the sun, wherever you are. Mercury, there it is. Mercury is a little bit bigger than the moon, tiny bit bigger than the moon. It's got lots of those craters on it. Those big craters, those holes that we see. Mercury is a rocky planet. Doesn't do very much. It has a little bit of water on the South Pole, but not too much. The interesting planet for me is Venus. Venus is about the same size as Earth, and it is the hottest planet, which is weird because, you know, Mercury is closer to the sun, closer to the fire, closer to the campfire, right? But Venus is the hottest planet. And I'm going to show you, it doesn't look very warm on the surface, but that's just the clouds. That's what Venus really looks like. Mercury, Ethan says, Mercury kind of looks like our moon. It really does. Mercury's just a little bit bigger. These planets, you know, the craters that formed on, not formed, but the rocks that smashed into them to form these craters, they all happened around the same time, about 3.5 billion years ago. And the moon and Mercury haven't changed very much since then. So those craters haven't disappeared. Just as many rocks hit the Earth, but the Earth is very good at erasing craters, right? It has wind and rain, it has volcanoes. Those are all things that eventually transform the surface and get rid of all those craters. But the moon hasn't really changed in about 3.5 billion years. Alex asks, why do other planets have more moons than us? Typically because they're bigger. I mean, Mercury doesn't have any moons. Venus doesn't have any moons. The only reason that Mars has 2 moons is that it's close to the asteroid belt, and Mars probably captured those asteroids. But Venus is the hottest planet because of its atmosphere. It has really thick clouds made of carbon dioxide. Those clouds trap gases, or sorry, they trap heat. And so even though Venus is farther away from the sun than Mercury is, a normal day on Venus is about 400 degrees Celsius, as hot as your oven at home. So you don't really want to go there. It also rains acid, which is not very nice, and has high enough pressure that it's like being 100 meters below the ocean. So not very fun. You'd be crushed, you'd be burnt, you'd be melted. Not very nice. So we don't go to Venus typically. But that's Venus. Mars, a little bit colder, less air, less atmosphere. Mars has the biggest volcano in the solar system right here called Olympus Mons. Olympus Mons. Ali asks, have humans only traveled to the moon or also other planets? Ali, human beings have only been as far as the moon. We have sent robots to all of the other planets, spacecraft, I should say, robotic spacecraft, but not all of them have been landed on. But human beings, the farthest that a human has been is the moon. And it takes 3 days to get to the moon, 3 days there, 3 days back, whereas Mars actually takes 9 months to reach. 9 months to reach Mars. So quite a bit longer. 4 years to reach Jupiter, which is our next planet. And Jupiter is the biggest planet. So when we were talking about, sorry, Alexis, not Alex, I'm sorry I got your name wrong. Alexis was asking about why do other planets have more moons? They're big. This is Jupiter. Jupiter has 79 moons, and that's because it captures asteroids all the time. If a stray asteroid goes by Jupiter, Jupiter's got so much gravity, it's like, yep, you're mine now. That's how it works. And so, so over time, Jupiter has captured a lot more things. Bigger planets can also have bigger moons. In fact, the 2 biggest moons of the solar system belong to Jupiter and Saturn. I'll show you those moons because they're actually kind of interesting, and they're very big. The 2 biggest moons in the solar system are Titan and Ganymede. And those 2 moons are actually bigger than the planet Mercury. 2 moons bigger than a planet, which is kind of crazy. Ethan says, doesn't one moon on Jupiter have a volcano? Yeah, that would be Io. I'll take you to Io. This is not Io. That's still Europa, our potato moon. So let's go to Io. Io has active volcanoes because it's so close to Jupiter. Jupiter's gravity is pushing and pulling on it. It's bending and twisting, and that heats up the core. And so Io actually has a ton of volcanoes, and you can kind of see them on the night side there. But those volcanoes release a lot of sulfur. And oh, look at that. There's actually an eclipse right now on Io. That's kind of cool. So Io is the sun. The sun is, sorry, it's hard to see. Let me brighten it up a little bit. So you see the sun's actually behind Jupiter, and Io is eclipsed right now. So that's kind of awesome. Very cool. So there actually are active volcanoes on Io. So Jupiter and Saturn. So lava comes out of the volcano? Yes, it does. Yes, it does. How long does it take for Mars to orbit the sun? Lavina asks. 687 days. 687 days. And Alexis, moons are not considered planets because moons orbit planets. Planets orbit a star, and moons orbit planets. That's kind of the general definition. Okay, so we've got Jupiter and Saturn. Saturn has the most moons in the solar system, 82, more than Jupiter. And then we get to the ice giants, Uranus and Neptune. And I'm going to include Pluto, even though it's not a planet. We call it a dwarf planet. But I'm going to include Pluto because someone was asking about it, and I want to talk about why Pluto is not a planet. So Pluto is really small. Excuse me. We have Neptune there. We have Uranus. Blue and green because of a gas called methane. Alyssa, I like that. My very easy method just sums up naming planets. You don't even have to worry about Pluto anymore, but yeah, that works. So we have 4 rocky planets, 4 gas giants, but here's the fun part. Here is the sun. Let me show you how big the sun is. It is going to be a little bit bright. I'm going to warn you. Ethan, Saturn's ring doesn't look very good in this program, so I'll take you to Saturn so we can take a look at it. But here's the sun. It's going to be bright. That's how big the sun is. 1 million Earths can fit inside the sun. So stars are generally bigger than planets. And stars, as you can see, give off their own light. They're basically giant nuclear bombs exploding all the time. Very, very warm. But they give us light and energy and life. It's hot. Don't go to the sun. You won't make it. Okay, so let's take a quick look at Saturn, and then I'm going to talk about why Pluto's not a planet anymore. So that was a long time ago question that I said I would answer, so I'm going to talk about that. But first, we're still at Io. We're going to go and visit Saturn. Saturn looks really nice in this program. Again, it's called Space Engine. It's not free either. This one I think is about $40 as well. But I use it all the time. It's super fun. Ali says Saturn's rings are actually asteroid belts, right? They're not quite asteroid belts. When we talk about belts and asteroids, they're generally things that orbit the sun. Rings are typically things that orbit planets. So if anything, they're actually more like tiny little moons. If everybody so kindly would make a fist, that's about how big Saturn's ring bits are. They're bits of ice about the size of your fist. And there's billions of them all going around Saturn like tiny little moons. So Saturn's rings are actually, in fact, like a bunch of little moons. They're very beautiful. And we actually do have moons in the rings as well. Some of the moons in the rings are actually using their gravity to pull away those little bits of rings. In fact, in about 1 million years, Saturn's not going to have rings anymore. So set your watch. 1 million years from now, Saturn will no longer have rings. Which is kind of crazy, kind of exciting. Okay, let's talk about Pluto. I'm just going to load up a thing I've got here. Look at all my random simulations that I've got. Okay, so this is our solar system. It doesn't look like it yet, but I'm going to bring up the names and orbits. I have to peek around my camera to actually see everything. So these are the planets. This is where they orbit, and we're going to go to right now. That's better. Okay, so we have Mercury, Venus, Earth, Mars. Ceres is a dwarf planet that's in the asteroid belt. Jaya asks, does that mean Earth could have had rings in the past? It's possible, although very unlikely. Because Earth is a lot smaller, it has less gravity than something like Jupiter or Saturn. And so it can't really hold on to those little bits of ring particles. But I will tell you that actually Jupiter, Uranus, and Neptune all have rings. They're just very, very dark and harder to see. Saturn's rings are made of ice, so they're much brighter, much more visible, much more reflective, a lot easier to spot. A dwarf planet is kind of like a planet, just smaller, Ali, and that's what we're going to talk about now. That's kind of why Pluto's not a planet anymore. All right, so we have Ceres, one of the dwarf planets. It's actually in the asteroid belt between Mars and Jupiter. Ceres used to be an asteroid and then got upgraded to a dwarf planet. So even though Pluto was downgraded, Ceres got upgraded. But I want to go out past Neptune. So we have Pluto here. Now Pluto, when it was discovered in the year 1930, it's right down there. When it was discovered in the year 1930, it was the only thing out there. There was Uranus and Neptune, and there was Pluto, and that was it. That's all we knew about in the whole solar system were the planets and Pluto, which was a planet at the time. In the 1980s and 90s, we started finding other rocks. And I'm going to show you how many rocks we found. These are asteroids. Every white line is another asteroid. So there's lots of them, right? There's tons. You can see the asteroid belt between Mars and Jupiter, very close to the center. This other clump of them way out here is called the Kuiper Belt, K-U-I-P-E-R, Kuiper. And the Kuiper Belt is a bunch of comets and asteroids and rocks that are out past Neptune. And it turns out that Pluto is part of that big belt. Now, because we started finding all these other things, we also started to find things that were as big as Pluto, including a couple of things like up here, you can see Aries. Aries is actually about the same size as Pluto. And so the question became, if we have planets, should we have 8 planets in our solar system? Or should we have 10 or 11 or 12? Should all of these things be planets? Or should we come up with something else? And the answer ended up being that we came up with a new definition for a planet. So to be a planet, you need 3 things. 3 things. The first thing, to be a planet, you have to orbit the sun. Pluto definitely goes around the sun. No problem there. The second thing, you have to be round like a ball. This is my squishy moon. To be round like a ball, which means you have to be big enough that gravity pulls you into a ball shape. There's some asteroids out there that are kind of football shaped, and we saw that with Phobos, right? So Pluto is actually round, like a ball. But the last thing is the most important one. To be a planet, you have to be alone in your orbit. Alone in your orbit. Planets like Jupiter and Saturn and Uranus and Neptune are so big that if any rocks try to get close to them, they get booted out. So those planets are effectively on their own in their orbit. But Pluto, we said before, is part of the Kuiper Belt. It's part of that big clump of comets and asteroids. And so because it doesn't satisfy that third condition, we say that Pluto is a dwarf planet. So a dwarf planet orbits the sun, is round like a ball, but is part of a belt. And that's why we have 5 dwarf planets. We have Aries, Pluto, Haumea, Makemake, which is my favorite one to say, Makemake, and Ceres, which used to be an asteroid. Those are our dwarf planets, and that's kind of how it works. Okay, so let's talk about the galaxy. Yeah, we're going to talk black holes, Ali. Don't you worry, my friend. I'm going to show you the galaxy, and then we're going to talk black holes, and then I think we'll be out of time. But I would love more questions if anyone is interested. So let's go back to Earth. Earth. Do we know what's inside a black hole? We don't. And I'll talk about why very soon. But let's go back to the Earth first. Is it Ceres or Aries? Aries is the correct spelling. Oh, sorry. It's Ceres for the dwarf planet. The dwarf planet is Ceres. A constellation is Aries, Aries. So sorry, that's a pronunciation error on my part, but Ceres with a C is how we pronounce that dwarf planet. Okay, so here's our Earth, and we're going to go take a look at the sun. Sorry for the hiccups there. Okay, so there's the sun, and you can see the Milky Way in the background. This is the coolest part of this program, and I'm going to show you why I love it so much, is that we can start to travel away from the Earth, and we can actually go faster and faster. So we're going to go up out of the galaxy. And as we speed up, we're actually going faster than the speed of light. We're traveling faster than anything can actually travel in the universe. So we're breaking the laws of physics right now. I just want you to know that. Does Einstein's equation apply to a black hole? Yes, it does. It absolutely does. Now, Sebastian, I know you earlier on, you asked if you could ask a longer question. Whenever you want to do that, just let me know, and I'm fine if you want to unmute and ask that question, okay? But we're going to go faster than the speed of light. All the way up, we're going to see stars pass along, go past us. The yellow lights on the planet, Ali, are cities. You can actually see cities from space. People make light, and they can be seen all the way from outer space. So if you ever see the International Space Station, they can actually see human cities on Earth, which is really cool at night. So as we go faster and faster, we start to see stars move. And as we go even faster, we're going to see that our Milky Way, that big streak of light in the sky, is actually a galaxy. We live inside this galaxy. Earth is one planet. We think there's about 1 trillion planets in our Milky Way. 1 trillion places where there could be plants or animals or life. Well, those are all life, but you get the idea. This is our Milky Way. This is where we live. It is another galaxy, just like Andromeda, just like the one we looked at before. And it has 400 billion stars, just like Andromeda does. But the really crazy thing is all this other stuff. You see all those other dots? Those are all galaxies, every single one. Every one of those galaxies, those dots, has hundreds of billions of their own stars. And I can actually show you a real picture of them. Every dot in this picture is a galaxy with hundreds of billions of its own stars, just like Andromeda. How many of those stars have planets? How many of those planets have life? There's a lot out there. Let's go talk about our black hole. So there could be more planets, but they aren't discovered, right? That's right, Lavina. We haven't found a lot of planets yet, but based on the ones we have, we can do some math and figure out that there should be about 1 trillion planets in the Milky Way. Okay, so let's go to the black hole. The black hole in the center of the Milky Way is called Sagittarius A star. We think that there's about 80 million black holes in the Milky Way, but most of them are really, really small. That's a lot of black holes, I know, but most of them are really small, and they don't do anything, so we don't know where they are. Big black holes, like the one in the center, that weighs about 4 million times as much as the sun. So it's a huge, heavy, big black hole that's sucking up stars and gas and dust. And as it sucks up the gas and dust, it glows. And we can see that glowing all the way from Earth. So that's how we know there's a black hole in the center of the galaxy. And as we go all the way to the center, we're going to go and visit this black hole. In the very center of the Milky Way, there's a giant star cluster of some of the biggest and hottest and brightest stars that we know of. And we're going to go inside to see this black hole. Can it suck up a rocket ship? Definitely. Black holes will tear up anything if you get close enough. But if you stay far enough away, you're going to be just fine. So let's go into this star cluster of massive bright stars of all different colors. And in the very center is called a supermassive black hole. That's this big one that we're going to see shortly. As we get closer, how far away do you have to be? Oh, to be safe, probably a couple million kilometers. But luckily, we're very, very far away from any black hole. So we don't have to worry about Earth. And also, it depends on the size of the black hole, Ethan. So if you get too close, if you're far away from a small black hole, that might be too close to a big black hole, right? So let's dim the lights a little bit because this thing is so bright. And we're going to follow it. Perfect. Okay, so we can see it looks a little bit different. As we move in closer, when a black hole is kind of sucking up a star, it has this big kind of a disk shape around it called an accretion disk. And as that accretion disk, as stuff starts to spin into the black hole, it all heats up. And as it heats up, it glows. And that glowing we can see from across the universe. So we can see black holes in other galaxies because they're so bright, they're glowing. There's two big jets shooting out above and below this thing. But in the very center, if we dim it down enough, you can see the black hole itself. The black dot, the black hole, that is called the event horizon. That's the place where if you cross that boundary, you can never come back out. The gravity is so strong that even light itself cannot escape. Does the black hole go into another dimension? Well, by definition, a black hole is another universe. It is a closed system where nothing can escape. So a black hole is by definition another universe. Maybe it doesn't lead anywhere, but I will tell you, if you were to go into a black hole, you'd probably be shredded to bits before you even got in there. If it's sucking stuff in, doesn't the stuff have to be excreted somewhere? No, not at all. It actually becomes part of the black hole itself. Black holes are basically a big bunch of compressed matter, okay? One of the cool things about it as you get really close is it actually bends light around it. So you see this stuff kind of back here, that's actually the light from behind it getting bent over top of the black hole. Now, if you did fall into a black hole, let's say you went in feet first, the gravity on your feet would be so much stronger than the gravity on your head that it would pull you apart like a piece of spaghetti. It's called spaghettification. Everything that goes into a black hole can never come out because it would have to travel faster than the speed of light to escape. Nobody has ever been sucked in, but even if you could go in, even if somebody was sucked in, there's no way to know because they can't send anything out. Once you go in, there's no coming back. And that's our show. I'm going to turn on lights. It got dark really fast. But that's that's it. That's all I've got, my friends. That has been the hour. Alexis asks, why are stars different colors? Because of their temperature. Hotter stars are blue, just like the hottest flames in a fire. Colder stars are red, and they're still pretty hot, 3,000 degrees. But red is the coolest stars, then yellow, and then white, and then blue. Did we literally go inside a black hole? Not literally, just figuratively, because we were in a program, right? So we got to see what it looked like. Okay, I'm going to pass it back to Alyssa and Sophia since we're done. That was awesome. Thank you for those wonderful questions. Those were really great. And that makes it more fun for me, let me tell you. So I'm happy to answer some more, but it's up to the showrunners here for what we want to do next. Thanks for the questions. That was really fun.
Sophia and Alyssa?
Okay, thanks so much, Ryan. That was like amazing. As a bio person, I don't know anything about space. So that's really
Fair enough. I don't know anything about biology, so I'm sure there's lots you could teach me too.
Yeah, for sure. Thank you so much. That was amazing. I hope everybody enjoyed. Just as a bit of a closing for everyone who came here, we want to do a little bit of a contest. So what we'd like you to do is for you guys to draw something that you learned and then submit it to us. You can submit it to us in two ways. You can post it on Instagram and tag us, or you can send it to an email, which I'm going to send all the details in the chat. And if you submit your drawing, we're going to pick a winner and you can win a prize of a gift card. So I'll just send all that information in the chat. And I don't know if Alyssa or Allison want to say anything.
Yes. So first of all, thank you so much to Alyssa as well as Sophia for organizing this event. They're busy themselves as students and, and they're in sciences and they want to help inspire and encourage everyone, all the students here to continue exploring science. Also want to thank Ryan from Astronomy Action, and he has a show. When's your next show, Ryan?
Oh, the next public one is this one, the Spectacular Solar System. That's going to be on January 23rd, which is next Saturday. And of course, we're just going to talk about the solar system, but we're going to do quite a few more as well. So you can see exoplanets and aliens will be after that. So thanks. Feel free to check out the website to find access to those too. Thanks, Allison. That was really fun.
You're welcome. No, thank you. And also to a shout out to our other STEM It Up members here, Yara, who designed our logo, and she's in grade 7, and Shrevani, who's also another member. Our next workshop is, when is it? On the 30th of January. And it is about science and the brain and how anxiety affects the brain. So it's really interesting. And we're actually focusing on the teen brain. So if you love science and are interested about human biology, just come check it out. And that'll be actually our math team that'll be spearheading that project. So follow us on social media at Get Together TO, as well as the STEM group. And I think that's about it. Any other questions? We have a whole bunch of workshops coming up. We are streaming them live now. And we encourage you to write to us and let us know what other things you want to learn. And, our student ambassadors who are high school and post-secondary students would be happy to help share their knowledge and information with you. So thank you.
Thank you.
Thank you, everyone.
Thank you.
Fantastic.